Aha! This is the amazing, the incredible, the wonderful Kurta mechanical calculator. It is affectionately known as the pepper grinder calculator because of its unique shape. And it functions like a pepper grinder. You spin the top. I don't know if you can see the numbers moving. Oh, it's musical. Isn't that lovely? And there's no electricity involved in this. It's entirely mechanical. There are no batteries hidden under the cover. This was invented in the 1940s and is a marvel of precision engineering. In fact, its inventor was an inmate in a concentration camp in Germany when he invented this. And in fact, he almost certainly would have been killed if it had not been for this invention, which the story goes the Germans intended to give to the Führer at the conclusion of World War II. Well, how does it work? Let's enter a number here like 222. 222. There we are. Now I'm going to add that to our result, which currently is 0. I'm just going to turn the pepper grinder once. Maybe you heard the clicking. Now you can see the result is 222. Now I'm going to multiply that number by 3 by just spinning this twice more, so for a total of 3 spins. That's once, twice, 3 times. Now we have 666. Lucky number. Actually, I don't like that number, so I'm going to subtract 222. To subtract, we lift up the lever. We've got the red ring that shows that we're doing subtraction, and we give it a little spin. Clickety-clack, and now we have 444. So I just subtracted 222 from 666. So it's really a very elegant mechanism, very simple to use, and yet incredibly powerful. Now, just for fun, we're going to do a more complex calculation. How about 485 times 98? So I'm going to first set the sliders here to 485. Then I'm going to clear out my result register and my counter register with the clearing ring. Use your thumb here and lift up the carriage and then swing this around 360 degrees. Now it's all zeros. And now I'm going to take 485 and I'm going to use a trick to multiply by 98. The trick is the carriage. Right now it's pointing at 1. That means one swing of the grinder is 1 turn. If I put it on 2, it's 10 turns. If I put it on 3, 1 turn multiplies by 100. You'll see that in just a second. So I'm going to do just that. I'm going to just turn this 1 time with the carriage set to 3. And if you look on the counter register, you'll see I've turned it effectively 100 times. So what we have then is 485 times 100 is 48,500. But wait, I want to multiply by 98, not 100. So I'm going to move the carriage back down to 1. I'm going to do a subtraction of 2 turns by lifting up this lever. Now we got the red subtraction ring showing. Then I'm just going to turn it twice. Watch this. Once, twice. So we see that's 98 turns effectively on the grinder times 485 is 47,530. Now, I don't know about you, but I would have had trouble doing that calculation in my head. These calculators were pretty darn powerful considering their entirely mechanical nature. Now, I probably shouldn't do this, but I thought you might be as curious as I was to see what goes on inside a Kurta. So let's take a look. It's quite hard to get this off. There we are. Here is the internal mechanism of the Kurta. It's amazing, isn't it? Now the Kurta is known as a stepped drum calculator, and you can actually see the drum. It's that shiny metal thing at the very center of the calculator. You may be able to see it more clearly as I move it now. What it is it's a metal drum at the center, and there's a variable number of teeth on it depending on how high or low you are. There are no teeth at the top, and there are 9 teeth at the bottom. And so those teeth will catch the digit of the sliding mechanism here. And so if the digit of the slider is 0, it'll catch no teeth of the step drum as it passes by. And if it's at 5, it will catch 5 teeth of the step drum. Maybe if the light's good, you can actually see it. It's turning 5 times every time I pass the step drum pass. We can go up to 0, and maybe you can see that it doesn't turn at all as I pass the step drum. So in that way, the step drum will affect every digit differently depending on where the slider is as the step drum passes. And every slider then will affect one of the digits on the result register. So, as you can see, here I have a 0 on the first digit of the result register. I'm going to move my slider down to 5. Let's make sure I get it right. 5. Now I'm going to pass the step drum pass, and it will advance that digit to 5, as you see there. And that same process applies to every digit as it works its way around the calculator. So it's really a marvelous mechanism, so elegant, so simple, yet it's ingenious. And now if we want to put the calculator away, we would normally get the sliders up to 0. We would set the clearing ring and swing it around so that it all zeroes out. And then we would fold away the clearing ring by pressing the magic button. Fold that right out of the way. Then we'll bring our container over here and put it in there nicely. And then you give the top a little spin in the counterintuitive counterclockwise direction. And there you have it, the Kurta. An amazing calculator, so compact, so elegant, and the history of it is just fascinating. If you have a little time, you might look up Kurt Hertzstark and read about his history.